let's find some derivatives that involve the exponential function e to the x. All right, if f of x is this function here, then the derivative f prime of x in Newton's notation will be 5 times e to the x, because the derivative of e to the x with respect to x is just itself, e to the x. This will be minus 12x cubed by differentiating this term. This will differentiate to a plus 9, and the 16 will differentiate to a plus 0. G prime of x. Now, even though this has an e in it, it is not of the form e to the x. Right? Notice where your variable is. So this is just a power rule. This will differentiate to minus 7 times e, because the e moved down, x to the e minus 1. Now, this term is the exponential function, so we will differentiate that. It differentiates to itself. This, even though it has an e in it, is just a constant. There's no x's there. The derivative of s with respect to t, here we have a chain rule. If we want to differentiate s with respect to t, t is in the exponent, so this is an exponential function, but it's not just t, it's t cubed. So the chain rule tells us to differentiate the exponential function first, 2e to the t cubed, because the derivative of e to the t cubed with respect to what's on the inside of that exponential function, t cubed, is just itself, right? The derivative of e to the x with respect to x, that x could be anything though, is equal to just itself. So back to our problem. This term by the chain rule differentiates to 2e to the t cubed times the derivative of t cubed. And we have a plus 5 by differentiating that term. So we can clean this up just a little bit. 2 times 3 is 6. There we go.